Welcome to qnawire.
So the first part of the question is asking us to basically list what we can deduce from the given quantities. So we know that we've been given a mass of 2.0 kilograms. And we also know that we have a spring constant K of 18 newtons per meter. So what kind of quantities can we have from M and K? Well, it should immediately pop out in your mind that we have this equation that F equals to 1 over 2 pi times M over K. And we know the M and we know the K, so we should be able to calculate F from here. Let's plug in numbers and do the calculation. So 1 over 2 pi times square root of 2 kilograms over 18 newtons per meter. And I think I wrote M over K upside down. So instead, it should be M. M over K is the one for T. So F is 1 over 2 pi square root of K over M. That should be over 2.0 kilometers. The density would be 3 pi, which is 0.95. And since we know F, it should be very easy to calculate T from there as well. So T would be equal to 1 over F. So 1 over 3 over pi, which is pi over 3 basically, and we should have 1.047 as second. And those should be the two quantities that we can list to answer this question. And the part B is asking us if we have another spring that's placed parallel to what we have now, what kind of time period, what is the time period we're going to have? So in order to think through that, we need to think about how the spring, like if you have multiple springs, how their spring constant work together. Since we know that those two are placed in parallel, the added up spring constant is pretty much just the two spring constants. You simply just add them together. So if we name the new one the total spring constant K prime, we're going to have 218 newtons per meter because the new spring also has the same spring constant, and we just add together. So 18 plus 18 give us 36 newtons per meter. That's our new spring constant. So it's the new time period T prime, which is you plug in the new spring constant. So equation 1 over 2 pi. This time is actually M of K because we're calculating T. And you plug in all the known numbers we have in this equation. The M is still the same because the only thing we did was add another spring. So we still have the same mass, 2.0 kilograms over a new K prime. I should write K prime here. So we're going to have 36 newtons per meter. If we run the calculation, it should eventually give us something that's close to 1.80 seconds, and that's the time period.